Let's jump right in. Have you ever stopped to think, how could you possibly measure the world around you without using light? Sounds kind of crazy, right? Well, today that's exactly what we're diving into, how to literally see with sound.
So let me ask you something. Picture this. You're in a room with absolutely zero light. I mean, it is pitch black. How do you see what's in front of you?
Well, the answer is pretty incredible. You use sound. Seriously, this is a superpower that animals like bats and dolphins totally mastered ages ago. They send out sound and use the echoes to navigate, to hunt, all in complete darkness. It's called echolocation, and it's basically nature's own super advanced sonar.
Okay, so what if we could steal that superpower for ourselves? Well, guess what? We already have. We've developed some amazing tech that perfectly mimics this incredible ability, letting our own inventions see the world using sound. And that brings us to the star of today's show, the ultrasonic sensor. So what is this thing? At its core, it's a device that measures distance using sound waves. But here's the cool part. The sound it uses is at a frequency so high, we're talking above 20 kilohertz, that it's completely beyond what we humans can hear. It's literally seeing with a voice that's silent to us. How cool is that?
All right, so you're probably thinking, this sounds complicated, but you'd be surprised. Getting started with this is way simpler than you'd think. Let's take a look at the essential toolkit you'd need.
Seriously, you only need 4 main things. First, you've got the Arduino Uno. That's the brain of the whole operation. Then, of course, the ultrasonic sensor itself. You can think of it as the eyes and the ears. You'll need a few jumper wires, which are kind of like the nerves connecting everything up. And finally, a breadboard, which acts as the skeleton that gives the whole project its structure.
And out of all those parts, we're really going to zero in on this one little guy, the HC-SR04 sensor. This thing is an absolute marvel. It's super common, really easy for beginners to use, and honestly, it's the component where all the magic really happens.
So the big question is, how does a simple little ping of sound actually measure distance? It feels like it shouldn't work, but it all comes down to the super simple physics of an echo's journey. Let's break down exactly how it works.
Okay, to get this, we need to look at the 4 little legs, or pins, on the sensor. Each one has a very specific job. You've got VCC for power and ground to complete the circuit. Standard stuff. But the 2 we really care about are trig, which is short for trigger, and that's the one that sends out the sound pulse, and then you have echo, which, you guessed it, listens for that pulse to come bouncing back.
And this whole thing happens in 4 incredibly fast, simple steps. Step 1, send. The TRIG pin sends out a short ultrasonic pulse. It's like a tiny, silent shout into the void. Step 2, reflect. That sound wave zooms out, hits an object, anything in its path, and bounces right back. Step 3, receive. The echo pin, which has been patiently listening this whole time, detects that reflected sound wave. And finally, step 4, calculate. The Arduino, our brain, measures the exact time it took for that sound to make the round trip and does a quick bit of math to figure out the distance. It's brilliant.
So, when you boil it all down, the entire measurement, all this seemingly complex tech depends on one super simple thing: just timing the echo's round trip. That's it. That is the secret sauce to the whole operation.
Okay, so the theory makes sense, right? Now let's get practical. How do we actually wire this thing up and give it a brain to do the work?
First things first, you got to give it power, and not super easy. The VCC pin on the sensor goes to the 5-volt pin on the Arduino, and the ground pin goes to, well, the ground pin. And boom, just like that, our sensor is alive and waiting for instructions.
All right, next up, let's connect the mouth. That's the trig pin, the one that does the shouting. We'll connect that to a digital pin on the Arduino, let's say pin 9. This is literally the connection that lets the brain tell the sensor when to speak up.
And of course, if you have a mouth, you need ears. So finally, we connect the echo pin. This is what listens for the reply. We'll hook that up to another digital pin, say pin 10. And there you have it, a direct line for the sensor to tell the brain exactly what it heard.
And just like that, the whole circuit is complete. The Arduino is now the official command center. It's in charge of triggering the sound, timing the echo with incredible precision, and then crunching the numbers to turn that time into a real physical distance. And it does all of this in a tiny fraction of a second. It's just amazing.
So you might be thinking, okay, that's a cool little project, but why does this really matter?
Well, it's because this exact simple principle is the engine behind a ton of technology that you and I use every single day.
I mean, just think about it for a second. You know the parking sensors in your car? The ones that beep like crazy as you get closer to a wall? Yep, that's an ultrasonic sensor. Those autonomous robots that can clean a room without bumping into your furniture? You got it, same tech. They're used for measuring water levels in big tanks, for home security systems, even for those smart trash cans that magically open when you get close. It's everywhere.
And that's really the key takeaway here. This incredibly simple, elegant principle, just sending out a sound and timing its echo, is at the heart of all these totally different technologies. It is the perfect example of how a simple idea can have an absolutely massive impact on the world.
So, that brings me to my final question for you. Now that you get the basic idea behind this amazing technology, what would you build? What problem would you solve with a sensor that can literally see with sound? The possibilities, as you can probably imagine, are just endless.